Dear students, in this video we will learn how to convert the base of a number into another base. So here we'll consider four number system. One is decimal. Okay, so first one is decimal number system. Second one is binary number system. Okay, third one is octal number system. So these are the most widely used number systems. Okay, and the fourth number system is hexadecimal number system. I have assumed here that you are familiar to these number systems. Okay, so in case of decimal number system, we have basis 10. Okay, in binary number system, basis 2. In octal number system, basis 8. And in hexadecimal number system, basis 16. Okay, now we will consider one example and we will learn how to convert this number from one number system into another number system. That means we will convert the base of these numbers. So please watch this video till the end, because after watching this video you will learn how to convert any number in any base system to another base system. Okay, so here we will consider one example. So suppose here we have one example. Suppose 171 in decimal number, and we have to find out the respective binary number of this decimal number. Okay, suppose we have to find out the octal number equivalent, and suppose we have to find out the hexadecimal number equivalent. So you know that in binary number system we have 10 digits. Okay, so the digits are from 0 up to 9. In binary number system we have 0 and 1, and in octal number system we have from 0 up to 7, and in hexadecimal number system we have from 0 up to 15, and 15 is denoted by F, 10 is denoted by A, 11 is denoted by B, 12 is denoted by C, 13 is denoted by D, 14 is denoted by E, and 15 is denoted by F. So now we will take this example and we will see how to convert into another number system, and after converting we will learn some shortcut methods. Okay, so watch the video till the end. So suppose first of all we want to convert this decimal number 171 into its binary equivalent. So what we have to do, we have to divide this decimal number by the base to which we have to convert. Okay, so here we want to convert into binary. In binary number system we have basis 2, so divide this number 171 by 2. 171 divided by 2. So what will be the answer? So here we'll have 8 and 5, 85, and remainder is 1. Okay, now this 85 is greater than 2, so we have to again divide. So 2 into 4, and here we'll have 2 into 2 is 4. Okay, so the remainder is 1. So here we have to again divide 2 times. So here we'll get 21, and the remainder is 0. Okay, again you have to divide this by 2. So here we'll have 1 and 0, and the remainder is 1. Okay, so this is very simple. So here we'll have again divided by 2. So what we'll have, 5 times it is 10, so it will be 0. So 2 into 2 it is 4, and the remainder will be 1. Okay, next we can divide again because they are both equal. So again divide by 2, so it is 1, and the remainder is 0. Now after dividing in this procedure, you have to write these numbers in this fashion. Okay, that means from bottom into top. So what will be the binary equivalent of this number? 171 in 10 base 10 is equal to, so you have to write from here, it is 1010 1011 1010 1011. So this is the binary equivalent of this number 171. So you have got this, how I have converted. That means whatever be the target number system, we have to take the base of that number system and divide the decimal number. Okay, that means here we have converted from decimal into binary. So the binary is the target number system. So here in binary we have the basis 2. So divide this decimal number by 2. Now suppose we want to convert into octal number system. So the base in octal number system is 8. So here we will again take 171 and divide it by 8. Okay. So here we'll have, so the remainder is 3. Okay. Next, again you divide. Okay. So what will have, this is the remainder and this 2 is less than 8. So you have to write in this manner. Okay. So here we'll have 171 in decimal number system is equal to, it is 253 in octal number system. So we have converted this decimal number dividing by 8 and we have written the remainder in bottom to top manner. Okay, and we have got this octal equivalent. Okay, now we have to find out the hexadecimal equivalent. In hexadecimal number system we have base is 16, so here we'll have 171, so we have to divide by 16. Okay, so here we'll have 10 is the quotient and the remainder will be, it is 11, and 11 is what? In hexadecimal number system it is B. 10 is A and 11 is B. Okay. So next again we have to divide. So we cannot divide because this number is less than 16. Okay. So you can stop here. So write in this manner, because this is not a hexadecimal number, you write in this manner. Okay. So 171 in decimal is equal to, it is 10. 10 is again A. Okay, it is A, B in hexadecimal. Now we have converted this decimal number into its binary, octal and hexadecimal equivalent. So what will be the shortcut? Suppose if you are in a competitive exam and you want to convert this number within a minute. So first of all, you have to convert the number 171 in decimal into its binary equivalent. So what is the binary equivalent we have got here? It is 10101011. Okay, 10101011. So this is the binary equivalent. So first of all, convert into binary, and after converting into binary, you can directly convert into octal number. Okay, and similarly for hexadecimal number. So what is the shortcut method? I will show here. So write down this number 10101011. So for octal conversion, make a group of 3. Okay, make a group of 3, and here we have two number. You put a 0 here and make a group of 3. Okay, so what is the equivalent of this number? So it is 3. So this one is 5 and this number is 2. Okay, that is 253. So here you can see this is 253. We have already found out by dividing. Okay, so after getting the binary number, you can directly convert from decimal 171 in decimal number into its octal equivalent, that is 253. Here you have to keep in mind that you have to take 3 bits at a time. So in case of octal number system, you have to consider 3 bits at a time. Okay, now let us see for hexadecimal number. So the shortcut method for finding out the hexadecimal equivalent will be similar process, but a little bit different. So 171 in decimal is equal to 10101011. So this is the binary equivalent number. Okay, so from this binary number we can directly find out the hexadecimal number. So write down this binary number 10101011. Okay, now what you have to do, you have to make a group of 4. Okay, because you know that in case of hexadecimal number system, you have from 0 up to 15. That means from 0 up to this 15 means F. Okay, so here you can say that 10 is denoted by A, 11 is B, and 12 is C, 13 is D, okay, 14 is E, and 15 is F. So here you can see this number is 8 plus 2 plus 1. So it is 11. 11 means what you can say? It is B. So you have to write here B. Okay. So this number is what? This is 10108 plus 2. It is 10. 10 means this is A. Okay. So we can write that 171 in decimal is equal to it is A, B in hexadecimal number system. We have converted this decimal number into 3 other base system. Suppose in exam you are not given with this 3 number system. Suppose in the question, suppose we have 171, suppose the same number, and we have to find out the number in base 5 number system. So what we have to do, I have already explained to you. That means you have to divide by the target base. Okay, so this number is in decimal 171. You divide by 5, it is 3, 4, and remainder is 1. So you have divide by 5, it is 34, and remainder is 1. So again you have divide this 34 by 5, so remainder is 4, and again you divide by 5 because this 6 number is greater than equal to 5, okay, or greater than 5. Quotient is 1 and the remainder is 1. So what will be the number? So 171 in decimal is equal to 1141 in base 5. So we have found out in this way. Now suppose we have some more complexity. Suppose the decimal number you are given has a fractional part. Suppose you have this same number 171 and we have some fractional part. Suppose it is 625. Now you have to convert this decimal number into its binary number system, okay, into its octal number system, and into its hexadecimal number system. Okay, so how you will find out? We have already converted this integer part, so we need not to convert because I have already found out this section. Now let us consider this fractional section. So we have to follow some steps for finding out the equivalent fractional part of this decimal fraction. Okay, we have 625. So what we have to do, if you want to convert into binary, you have to now multiply by 2. So watch it carefully. It is a little bit tricky. So 0.625. We have to neglect this part now. So we'll consider only the fractional part. So here we have 0.625. We have discarded this part. So it is into 2 because we want to convert into binary number system. So what we'll have? 1.25. So whenever you have an integer here, so you will write that integer here. Now we will consider this fractional part only because you have considered this integer here, okay, integer part. Now you will consider this fractional part. So 0.25. Again you have to multiply by 2. So what will have? It is 0.50. Okay, so what is the integer part? Integer part is 0. You write here. Next we have 0.5. So 0.5 into 2. So what will have? It is 1.00. So what is the integer part? It is 1. Now we have this fractional part is 0. So up to here you have to find out. So for this fractional part you have to see in this way. That means from top into bottom, and you will write here. So here we'll have 171.625 in decimal is equal to, in binary what we have, 171 is 10101011 point this number 101. Okay, this is binary equivalent. So here we have got the binary equivalent of this fractional number. Okay, now we have to convert into octal number system. So similar procedure, but here you have to now multiply with 8. In octal number system base is 8. So we will consider only the fractional part. Integer part we have already converted into octal number system. So here we'll have 0.625 into 8. So what will be the result? It will be 5.000. Okay. So what is the integer part? You have to write here. It is 5. So we do not have a fractional part here. So you have to stop. So in this way again we have to see. So the octal equivalent of 171.625 in octal, it will be, so integer part is 253. Okay, so here you write 253 and the fractional part will be 0.5. Okay, it is octal number. Now we will find out the hexadecimal part. Similarly 0.625 into now 16. So what we'll have? We'll have the value is 10.00. So 10 number you have to write here, this 10. So this 10 is represented in hexadecimal number system as A. Okay. So if we convert this 171.625 in decimal into hexadecimal number system, here we'll have it is integer part is AB, okay, point, this is fractional part, so it is A. So we have considered integer number as well as fractional number for converting from decimal into hexadecimal number system. We have seen from binary into octal and binary into hexadecimal number system in the shortcut method. Now let us learn how to convert from another number system into decimal number system. Suppose we are given a number in another number system, that is suppose binary, octal or hexadecimal number. Okay, now we have to convert into decimal number system. So suppose we consider the same number. Okay, this is AB, suppose A, this is hexadecimal number. Now in the question, suppose you are asked about to convert this number, okay, in 16 or hexadecimal number into decimal number system. So what we'll have? So we have to find out the decimal equivalent. Here you have to convert this number A, B, point A, hexadecimal, A into 16 to the power 1 plus B into 16 to the power 0 and plus A into 16 to the power minus 1, because this is fractional number. So you have to follow this procedure. Okay, that means 16 to the power 0, 16 to the power 1, 16 square, okay, 16 cube. In this way you have to follow. So A is 10. 10 into 16 to the power 1 is 16 plus B is 11 into 16 to the power 0 is 1 plus A means it is 10 into 16 to the power minus 1 is 0.0625. Okay, so here you can see it is 160 plus, so this one is 11 plus, so this number is 0.625. So what will be the answer? Here we'll have 160 plus 11, it is 171. 171 point, this number is after decimal. Okay, so here we'll have 625. So this is the decimal equivalent. So in the previous case we have converted this decimal number into hexadecimal number. Now we have done in the reverse process. So this is the reverse process you have to do in this manner. Now let us convert the octal number into its decimal equivalent. Okay, the octal number is 253.5 in octal. So 253.5 in octal, and we have to find out the decimal equivalent. So procedure will be similar, but you have to now multiply with powers of 8 because the base is 8 now. So here you can write it is 253.5 in octal equal to 2 into, this is the third digit. Okay, so here we'll have 8 square, okay, plus this 5 into 8 to the power 1 plus this 3 into 8 to the power 0, okay, plus, so 5 into 8 to the power minus 1. Okay, so here we'll have 2 into, it is 64 plus this is 8, 5 into 8, it is 40 plus it is 8 to the power 0 is 1, so it will be 3 plus 5 by 8. So what will be the value? 0.625. 2 into 64, what will be the value? It is 128 plus 40 plus 3, it will be 43 plus 0.625. Okay, so here we'll get it is 8 plus 3, it is 11 or 1 and carry is 1. Then we have 4 plus 2, it is 6. So with the carry it will be 7. Okay, and we have 1. And we have the fractional part is 0.625. So this is the decimal number. Okay, so you have got this. So we have converted from hexadecimal number into decimal number. We have converted from octal number into decimal number. Now we will convert the binary number. So similar process you have to follow, and we have the binary number is 10101011.101 in binary, and we have to find out the decimal equivalent. So here let me write down the sequence of 2 power. So first of all, here we'll have in the integer part 2 to the power 0, 2 to the power 1, 2 square, 2 cube, 2 to the power 4, 2 to the power 5, 2 to the power 6. Okay, in this way you have to follow. And after the fraction we'll have 2 to the power minus 1, 2 to the power minus 2, 2 to the power minus 3, and so on. So this is the sequence. Now we'll put these values here. Suppose here we have, this is after the decimal we have 101. So put values here 101, and we have 000 again. Okay, so you need not to consider this. So suppose here we have another number, that is 2 to the power 7. Okay, so here we have to put these values 10 10 10 10. So this is the number. After the decimal we have this 101. Okay, and the integer part is this. So now let us find out this decimal equivalent. 101011.101 in binary equal to, so we have to write 1 into 2 to the power 7. Here we can see plus 0 into 2 to the power 6 plus 1 into 2 to the power 5 plus 0 into 2 to the power 4 plus 1 into 2 cube plus 0 into 2 square plus 1 into 2 to the power 1 plus 1 into 2 to the power 0. Okay, plus after the decimal we have 1 into 2 to the power minus 1 plus 0 into 2 to the power minus 2 plus 1 into 2 to the power minus 3. You can see here, just you have to multiply in this manner and you have to then add. Now what will be the answer? So 1 into 2 to the power 7. 2 to the power 7 is 128, into 1 it will be 128 plus, so this is 0 multiplied by anything, so it will be 0 plus 1 into 2 to the power 5. 2 to the power 5 is 32 plus this is 0 again. Okay, and then we have 1 into 2 cube. 2 cube is 8. 8 plus again 0 plus this is 2 plus, and this one is 1. Okay, and plus we have plus this is 1 into 2 to the power minus 1. So 1 by 2. 1 by 2 means 0.5 plus 0 into anything, it will be 0 plus this number is 1 by 8. It is 0.125. So now we have to add these numbers. So what will have 128 plus 32, it is 160. 160 plus 8, it is 168. 168 plus 2, it is 170. 170 plus 1, it is 171. And here we have 0. This is 500. Okay, and it is 1 to 5. So here we'll have 0.625 in decimal number system. So we have got the same number in decimal number system previously we have considered. That means we have now proved that these numbers are properly converted. So if you have any question, please put it in the comment section below. Also like, share and subscribe to my channel. Thank you.